everyone. I hope you're having an amazing day. So today we're going to talk about compute expressions in Einstein Analytics, and we're going to look at how to slice a data set and probably schedule a data flow. That's pretty much what we're going to talk about. And after that, I'm going to talk about validation sets and machine learning. So if you haven't watched my machine learning videos, I would highly encourage you to go and watch my other videos about Einstein Analytics, where I've covered machine learning as well. So if you're someone who's not interested in machine learning, that's fine. You can stay till Einstein Analytics, then you can jump off. That's fine. That's your choice. But if you're someone who's interested to know machine learnings, then please stay till the end of the video. I'm not covering any programming side of machine learning, so please don't get overwhelmed. I'm not talking about programming. I'm not talking about, as I mentioned in my previous episode, I'm not talking about TensorFlow. I'm not talking about PyTorch. I'm not going to talk about neural networks, right? I'm just going to keep it very simple, nice and easy, so that you have a very basic understanding of machine learning. This is a very, very, very basic introduction to machine learning. Not talking any advanced concept. Machine learning is huge. Right? Okay. All right. Let's dive in. So first thing first, you need to register to your Einstein org, right? And I've covered that in my Einstein first video, where I talked about introduction to Einstein Analytics. In that, I talked about how to register for an org, right? Please go and watch the video if you don't know how to do that. Cool. So I've logged into my org. So what I'm going to do, I'm going to go to, so this is my setup screen, right? And then I go to this tic-tac-toe icon and go to Analytics Studio. And then I'm going to go to this data manager. So you can go to data manager in two ways, right? I mentioned from here, and other option is to go to the get code icon, and from there you can go to data manager, right? It takes you to your data manager. You can choose either way, right? It's up to you. Okay, so you got two way options here: Dataflow and recipes, data and connect. So we have worked with a demo Dataflow in our last episode, right? So we're going to work on the same. I'm not going to talk about recipes today. That's the topic for next time, right? So what we're going to do, we're going to talk about something called compute expression. So compute expression is very interesting, right? If you are someone who came from a programming background, you might know something called calculator fields, right? So compute expression is something similar to calculator field, where you will be creating a new field of using an existing field, right? So for instance, in our data set, right? Let me close this one. So currently, this data set, if you look at this data set, it's getting a data from two sources. One is the beer sold, and one is an account, right? And if you look at the beer sold data set, you have three fields like account, quantity, and total amount, right? So what we need to have another field based on account, right? So, sorry, based on quantity. So before I dive further, let me take you to the custom object which I've created. So that's the beer sold, so that it becomes clear what I'm trying to do here, right? So we have this beer sold, and come on, so beer list, right? So we have I populated some dummy information here, right? Beer sold name, quantity, total amount, right? So what I wanted to do, I wanted to create another field where if a quantity is between 0 to 10, so you should call that the quantity name as something called mild drinker, and if the quantity is greater than 10 and less than 25, we should call it as a medium drinker. I'm just making up a term, right? And then if it's greater than 5, call it as a binge drinker, right? So I just wanted to demonstrate based on the data what we have. So we are not using any of the, it's not a new field from an underlying database. It is a calculator field using the existing field. So if you're someone who uses SQL Server, if you're from another programming language, if you're from Oracle, you will know what I mean by calculate data set. If not, I will demonstrate what I'm trying to do here. So if you remember, I talked about SQL last time, and I decided I won't be talking much about SQL because this is an introduction to Einstein, and SQL is a bit advanced concept. So I will do that once I've completed this basic introduction to Einstein course. Then we talk about SQL in detail, right? So, but today, to demonstrate compute expression, I need to use SQL case statement. So please bear with me. If it looks a bit complicated, my apologies. I try to explain what I'm trying to do. If you have used your SQL server, if you know how to use SQL, then the case statement is pretty much similar, right? So okay, let me name this as say quantity name, right? And the source. So the source, what we're gonna do? See, if you look here. So we're going to look at the filtered data source, right? Okay, and merge with the source. So pay the special attention to it. So what happens is, let's say I'm going to create a, let's say my data set has, say, 5 fields, right? And I'm going to add a new field, let's say 1 field. So if I put merge with source, it will merge with the existing one and make it 5 plus 1, 6 field. If not, then you will only get 1 field, what we're gonna do create right now. So it's a good option to use merge with source, and I wanna add field, and let's say I wanna do quantity name. It should be test field, right? Okay, you know what? Let's cancel it. Quantity name compute. Okay, let me call this, and then gonna add field. And so we're gonna call it as, because we are relying on quantity, right? So compute, so not compute, sorry, quantity. You can name whatever you want based quantity name. So now here we're gonna write a SQL expression. So we're gonna use the case statement. So case when, so it has to be quantity underscore C. This is the field name, right? Less than, sorry, greater than equals to 0, and quantity underscore C is equal to less than equals to 10. Then we're gonna name it as something called what's that called? Mild drinker, right? So we're gonna do when, sorry, not this double quotes, right? Quantity underscore C greater than 10, right? And quantity underscore C. I'm just gonna make this as lowercase just for consistency, right? Less than equals to 25, then we can put it as, it should be double quotes because it's a string or text, right? Moderate drinker, right? And then we say when else, we can call it as a bench drinker. Okay, and then we end the case statement, right? So what we've done, so we have used the case statement, right? When quantity is greater than equal to 0 and less than equals to 10, then we call it as a mild drinker. When the quantity is greater than 10 and it is less than equal to 25, then we call it as a moderate drinker. Else we can call it as a bench drinker, right? You can also put when quantity, but just to simplify it, I just put it as, you know, else statement, right? Cool. Okay, now save it, and then you're gonna create it, right? Fantastic. Now, this is great, but there is a problem here, right? So the SFDC register, right, is still pointing to filter data. We don't want that. We want this to be pointing to this one, right? So go to this, and instead of filter data, we just change it to quantity name compute, right? That sounds good, right? And then update the flow. And run the data flow. That's all we have to do, right? So it's queued. It will take, as you know, if you remember last time I said, it might take a minute, it might take 2 minutes. So Yeah, so this is one of the things I'm gonna show you how it works. So while it gets running, right? So next thing we're gonna talk about the slice data set, right? In a slice data set, right? It's like you have a data set, right? We created using it this demo flow. You can slice it, right? Let's say I wanted to take some field out of it. I don't want a quantity, let's say, for instance. You can do that, right? Let's say I decided, okay, I don't want it to say, let's run, and I'll show. Okay, it's running, so we're gonna run. So what I'm trying to say was that if you have a data set, existing data set, let's say it has 5 fields, right? And you can slice that data set. Let's say you don't want 2 fields out of it. So your slice data set will be exactly the same data set, excluding 2 fields, right? So that will be 3 field data set. So it can be very handy for different scenarios. So we're gonna get into the dynamics of the slice data set later later episode, but today just a hands-on to demonstrate how to create a slice data set. Okay, so it's been successful. Now let's go to data here, and I have to see which one is it. So this is the account register one here, right? So let's go to explore and to demonstrate that new field I've created. So I'm gonna go to here, bar. So you see the quantity name? There you go. There you go. Binge drinker, mild drinker, and moderate drinker. Let's look at the data here. Right. So we got one binge drinker, which is a quantity 120. Makes sense. And then we got something called mild, which is 1. And then we got a moderate drinker, right, which is over 10. That got a 3 data here. So that's exactly what it is. So you see, this is exactly what I meant by that. It will help you to create a calculator field, which you can use in your charts and reports or whatever, right? Cool. All right, so now let's talk about the slice data set. Let's go back to the Dataflow recipes. So we got something called slice data set, this one. So you're gonna drop it here. Let's say sliced demo data, right? Okay, source, what we're gonna do, source, we're gonna do filter data. So we have keep and drop. So drops, what happens that if you wanted to take off a field, use the value drop, right? So I'm gonna say, I don't want the quantity, right? So I will create it. Okay, now we have this sliced data set. That's great, but I need to have one more reg SFDC register because I wanted to register this data set, right? Otherwise it won't work. So we're gonna have to do SFDC register. So we're gonna do sliced reg data set, right? So we have sliced demo data, that's a source, and alias we can say sliced demo data. And don't worry about the sharing source and sharing security predicate. We're going to talk about that later course, right? So later episode, what I meant. Okay, so this looks great. So now I'm going to update it, and I'm going to update the data flow. And we're going to run the data flow. All right, it's going to take some time, as usual. You know, it takes some time depending upon whatever it's doing behind the scene. So sometimes 10 seconds, sometimes like it took 47 seconds, right? This one took 25 seconds. So yeah, I mean, so, right. Okay, so it's gonna still run it. So then after that, I'm gonna demonstrate, how to do scheduling of your data flow because it will update the data flow based on schedule. So that's a very cool feature. So Einstein is pretty straightforward. It's not complicated, right? I mean, it's not rocket science that, I mean, if you're someone who's a programmer, Einstein is a piece of a cake. I mean, I'll be very honest with you. I mean, it's not difficult, right? I mean, if you're someone who came from other visualization tool, you'll find it interesting. Einstein is very good. I mean, it's a very stable platform. I mean, I really liked using Einstein. It's pretty amazing, though. So I give full credits to the Salesforce team, development team. So... Cool. All right. Okay. So we're gonna go to data here, and there must be something called slice demo data. And what we did, we actually took the quantity of, right? Okay. So let's explore to see if the quantity exists. If it exists, then there is a problem, right? Okay, so see the quantity gone from here. And so there's no quantity here anymore, right? Sounds good, right? Excellent. Right, so that's the slice data. Now let's go and do the scheduling. So we go to this data flow and recipes here, right? Demo data flow, and there is this drop down here, and you see a lot of options here. So you can download your JSON, you can schedule, right? And so you have time-based and event-based. So let's focus on time-based. So you can schedule weekly, hourly, so whenever you want, what time of the day, and you can run every 24 hours, and you can choose, this is similar like a Salesforce report, right? So something similar interface, right? Except that I don't think so you can email it something. But okay, so let me do time-based, and that's schedule. So it shows you when is the next run, right? And then you have notification, and then you have a lot of stuff here, right? And notification is when you want it to email, right? That's another thing. And then you can delete it, then you can run now, upload, edit, right? Upload your JSON file, and then you can edit. We'll take it to here, right? Sounds cool. This is pretty much straightforward, nice and easy, right? So we talked about how to create a data set using a Dataflow, and right, we used an existing example, right? We used a custom object and an account object, right? And then we created a augment, right? And then we used a filter, right? And then we have used the compute expression to create a calculated field, and as usual, you have to register it. And then we used the slice data from the filter data, and where we took a one field, and then we used the register data, right? And then we update her and run a data flow. Pretty straightforward, nothing fancy here. So if you look at the JSON here, this is how the JSON looks like. So if you are someone who don't understand JSON, don't worry about it. But if you're someone who understands the JSON, just have a look at it. So you see the cycle expression what we used here. So pretty straightforward, right? So yeah, this is how the JSON looks like. These all are arrays. Right, so yeah, just go through it in your spare time and see what it's doing, and you can even download it using here. And as I said, that before you do any kind of update on the existing data flow, it's always good to take a backup. The way you take a backup is using download, because for some reason, right, if you muck up the data flow, you can always upload the existing copy, right? So it's a good practice. I think it's the best practice in my opinion, because mistakes do happen, right? After all, we're human beings, right? Okay, so that's all I wanted to talk about Einstein side of things today. And I've read somewhere, there was an article I was reading, as written by one of the guy. They said they don't use Python behind the scene for Einstein. Instead, they use Golang, because they said the Python it has poor performance compared to Golang. I've used Golang, right? But I'm not sure how it's better than Python, because Python, I understand that Golang is catching up with Python. Python it's user-friendly, so much of extensive libraries. I don't understand the reason behind, if that is true. I mean, I'm not saying, I've read a blog about it. I'm not sure. I'll put a link to the blog below. If you guys wanted to have a read and put a comment, I will really appreciate, wanted to know, if that's the true reason why Salesforce decides not to use Python for Einstein Analytics, instead use Golang because of the performance. I mean, I haven't seen any performance issues in Python, right? But yeah, could be they might have their own valid reason, but yeah, it would be good to know, right? Because you're using a tool. I mean, I'm always interested in knowing the things under the hood, because as I said, I've been a programmer for almost 15 years, and I like to, dissect stuff, right? I just don't like to use the tool, because it doesn't make sense for me to just use a tool, click and tool like a functional user. I'm not a functional user. Although I must say that functional users are amazing. They did it, because without functional user, you will never have a great product, right? So programmers and functional users go hand in hand. So yeah, so we need to give credit to them for doing an amazing job to bring you need to have a team which have an eye for design and test the features from a user point of view, right? Sometimes programmer may not test the features from a user perspective, right? They test from a functional code perspective to see if the functionality works, but may not be good for in terms of user friendliness, right? All right, that's enough of that discussion. It's gonna end up being messy if I'm gonna end up into that discussion. All right, so enough wasting time. So we're gonna jump into machine learning now. So if you're someone who wanted to say adios now, that's fine. I thank you so much for your time attending today, Einstein Analytics. If you wanted to continue the journey further with machine learning, please stay on the call. And we will look into the validation sets today, right? Cool. Right. Okay, so we're going to get into, as usual, my favorite paint editor, because I like this for some reason. And I've actually turned off the notification pop-up. Hopefully it doesn't pop up today. So last session we talked about a concept of overfitting, right? Where how bad is, because when you have an overfitting, so the loss will be bigger, right? When you are training. So you have a model, right? So you have a model, right? And you train it with the training set, right? And you get a result, and you have some training loss, right? And then you have a test data, right? And this is called test. Okay, this is training, and this is your model. This is your model, and this is your test loss, right? Now, if the test, so now what happens is that if the test loss is somehow become greater, way greater than the the training loss, then you have an overfitting problem. So what I meant by that is that, let's say training data, right? Say you wanted to calculate the housing price, right? And you expose this model over a constant period of time with the training data, and you to predict an house price, right? And then you expose your model with the test data. So this is what we talked about in the last time, right? We divided the data set into two parts. Come on. That's right. Hang on. All right, we talked about two parts. One is this is the training, and this is a test, right? This is 80 to 20%, right? So we expose this training to this model constantly, and to get a machine learning model, right? And then we decide to deploy this into production, and we test this with the test data. But what happens if the result is not what we're expecting, right? So we end up in training the model by adjusting the learning rate and taking of the features, back and forth, and then we arrived a very valid model which satisfy the test data. But what happens is that it might arrive to be an overfitted model, right? So which is not really a good solution. So what's the best way? You have to go a lot of iterations, right? So the best way we can do is, right, we have something called validation set. So we're gonna divide the data set into three parts. One is the training, then we have validation, and then we have test. It's usually you can do 80-10-10, 80% of training, 10% of validation, and 10% of training, or you can do 10 and 20. This works as well. So what happens is, so you train your model, right, with your training data, and you keep on training it, and you get a decent model. Then you use the validation data set to train it, right, the same model. So if your validation loss, right, is way greater than your training loss, right, then there is an overfitting problem you have, right? And if your validation loss is way less than your training, then you have an underfitting problem. If your validation loss is almost pretty much similar to training, then your model is just right? Then you can use your training test data to train your model. Okay, let me explain in a little bit more detail so that it become very clear, right? Okay. So let me color this. Okay. Come on. Right. I've decided not to talk about regularization now because we need to talk about a few concepts before we get into that. Right. I'm trying to explain it in very simple term. I'm not using any mathematical equation. Right. Just to understand you the concept in a very simple English. That's what I'm trying to do. So that if you're a business analyst, it's fine. I mean, I'm not targeting this course for software developers. This is not a software developer course for machine learning because I'm not using any Python code or R, right? So hang on a second. Let me clear this. I think it's fairly good. Right. So we're gonna close this one. Okay. Now start again. Okay. Right. So what we're gonna do. So as I said, we divided this into two parts, right? We have training, we have validation, and we have test, right? So this is 80% of the data, this is 10% of the data, this is 20% of the data, right? These are labeled data set, right? Labeled data set, and this is unlabeled data set. Means we have a data set which is not labeled, right? So what happens is, so first we train our model with this training data set, right? And then we get a validation training loss. You know, if you remember my second lecture of machine learning where I talk about gradient descent, where we calculated the loss and the loss keep on decreasing, with each iteration, right? So you get some, training loss. Let's say loss is TL, right? And then once your model is trained, right, you expose that model with your validation data set. And then after each iteration, you will get a validation loss. Let's say your validation loss, this is M. Let's say your validation loss is VL, right? Now, if your VL, right, is way greater than TL, that means you have a overfitting problem. If your VL, right, is way less than TL, then you have underfitting problem. If your VL is just right to TL, right, then model is just right, right? So what happens is, so if you have an overfitting problem, then it's not a good solution at all. Then when you expose your test data to your model, right, then the result will not be what you're expecting. Then the model is faulty, basically, right? So what should happen is that you should train your model in such a way that the validation loss and the training loss should be just right, right? After that, you expose that model, because that model, once you expose it to validation, and if the loss is between the validation and the training is just right, that model is pretty much good for production, right? And now you expose that model to your test data, which is the unlabeled data set, right? Which means to say that a model has no idea about this test data. And so if it generates the expected result, that means the model is fine, right? Otherwise, what happens is that you put a model after just training without doing any validation, and then it could be a model, it could be an overfitting model or underfitting model. So the result will not be what are you expecting, right? So that's not good. So you have to pay very special attention. And so when you select, as I mentioned in my last lecture, right, when you divide a data set, right, into three parts, you have to randomize your data, right? It should not be case that all the category of one belongs here, other category belongs here, other category, no, that's not a good data at all. And please never ever train your data on a validation data. It is absolutely not going to work, right? And please never train your model, sorry, I said never train your model, not data. Never train your model on a test data or on validation data. You should only train your model on a training data set, right? So, okay, so there is another concept which I'm going to talk about next time, is a feature engineering, right? So I'll just give you a very concept. So what happens is that the data resides in a different different places, right? It could be in the form of a JSON, it could be form of a CSV, it could be form in somewhere else, right? In an XML, right? So you need to have data in a form of a feature vector, right? A vector is something like this, right? So like 0, 1, 2, something like, right? It's always good to have a data in a numerical form so that you can easily multiply with the weights and to get the desired output. So sometimes the data could be incomplete. Sometimes the data has a lot of strings, so you need to use encoding there, right, to get the right data. 75% of machine learning engineers' time is spent on the feature engineering, because they have to make sure that they get they engineer the data, massage the data so that it's suitable for the model, right? You can't, and plus a lot of they have to analyze the data, right? They have to work on it to clean the data. That consumes a lot of the time. So I'm going to talk about that in our next episode, right? So this is all I wanted to cover. So I hope you understood what I'm trying to say today. So instead of dividing a data set into two parts, we're going to, like into training, a test, we divide into three parts. That's training, validation, and test, right? So that will help us to create a better model, right? By squeezing the, tweaking the learning rate and other stuff, right? So, right, that's all I wanted to cover today. So I hope these sessions are very simple, right? If it's too complicated, please let me know. I'll try to simplify. I don't know how to simplify in a more simple way, but I can try if you find this session is too overwhelming. As I said, this is not for a programming people. This is not for a, this course won't make you a machine learning expert. Now, that's not my main intention of this course is about. It's all to give you a very basic foundation about machine learning. To, if someone talks to you about machine learning, right? Someone says to you, oh, look, do you know about gradient descent? You should be fairly confident to understand what the person trying to communicate, right? If you're a business user, if you're a business analyst, right? No one will ask you to write a code. Oh yeah, can you write that in the TensorFlow, please? Can you write that, in using Python? Show me how to do that. Now, if you're a business analyst, if you're a salesperson, they won't expect you to do. If you're a programmer, that's a different story. So this course is not for programming, for this machine learning, right? Cool. All right, so that's all I wanted to cover today. Seems like it's pretty starting to rain. It's very well, it's not unusual for New Zealand winter though. Right, okay, that's all I wanted to cover today. So thank you so much for attending. So next time we're going to talk about more stuff, right? So yeah, and one more thing, if you wanted to know about differential equation, I'm going to talk about differential equation in my 10 p.m. university. That's my next course, which I'm going to cover. So if you wanted to know differential equation, please stay tuned for my next video, right? All right, and if you like my channel, please subscribe. It's up to you if you're interested. All right, no pressure. All right, thank you so much for attending. Adios and greetings from New Zealand.